Hello, hello. Good evening, everyone. This is Subhrajyoti Moitra from MATLAB and Tech Chat. Uh, I have made this channel for uploading various videos related to MATLAB. Basically, this channel has been made has been created for demonstrating different operations, different demos on MATLAB, and also in Simulink platform. Different examples I will cover here. So this is a very simple example. Today we will discuss mainly on the electric circuit operation, and I have taken an example on the resonance that commonly occurred in RLC circuit. Who are from electrical background, they basically know this common phenomenon. This can be occurred in RLC circuit. Okay, if I apply an AC source in that RLC circuit and with the fixed parameters of that circuit, resistance, inductance, or capacitance, if I vary the frequency by keeping the voltage magnitude fixed, the resonance may occur at a particular point of frequency. Okay, so that is called the resonance frequency. So the problem is how we can solve this this problem in MATLAB. So here is the code in the MATLAB platform. You can develop the MATLAB code for simulating the RLC circuit. Suppose I have taken a simple example of RLC circuit where the parameters of the circuit I have taken here. The resistance value is 10 ohm, inductance is 2 Henry, and capacitance value is taken as 3 microfarad. As you can see that here the value is written 3 10 to the power minus 6, so that means it is provided in microfarad. The supply voltage is taken as 100 volt, and frequency is the only variable parameter. Why? Because we have to check the resonance condition by varying the frequency at step. We are starting the frequency value at 2 Hz, and we will move forward in this way, and the final value of the frequency is taken as 100. So between 2 and 100 we will vary the frequency value with a step size equal to 2. Okay, now we are deriving the formula for necessary formula we will derive here. That is omega equal to 2 pi f. We know that inductive reactance we have to derive here, omega into L, inductive capacitance also, and similarly here after that we are calculating the impedance value of the overall circuit. Now we are estimating the magnitude, and then after that we are calculating the current flowing through the circuit. Now generally here basically what we are doing here, after varying the frequency, that basically we are plotting here the two parameters. One is the inductive reactance and next is the capacitive reactance, and we will check how these two parameters will vary with respect to the frequency. Okay, how these two reactances will vary with respect to the variation of frequency. Okay, this is one plot. And second plot is we will check the variation of current also with respect to the variation of frequency. Okay, in this way we will check the resonance condition, and also we are also plotting the frequency versus voltage, inductive voltage. That means the drop occurred across the inductive reactance and drop occurred across the capacitive reactance. Okay, so if I run this program, you can see that three individual graph will appear at the output. This graph will display you the variation of these parameters with respect to frequency, because we are varying the frequency here. Now here you can check, this is the plot that we have. This is the plot that we obtained, that a variation of inductive and capacitive voltages with respect to frequency. As you can see that the blue line represent the inductive voltage or drop across the inductive reactance, and the purple line represent the capacitive drop. Okay, so a peak is occurring at a certain level of frequency between 60 and 70 Hz. Okay, and if I look at the second plot, you can check here that the variation of total circuit current with respect to frequency, the same type of graph we are getting here, the same response we are getting here from the current also, and the peak is occurring between 70 and 60 Hz. Okay, now here you can check the variation of the reactances of both of the inductive and capacitive part of your circuit. Here you can check the purple line represent the variation of capacitive reactance, and blue line represent the variation of your inductive reactance. So as you can see here that these two plots cut each other at the point somewhere between the 60 and 70 Hz. So we can expect actually where these two graph will cut, when the resonance will occur in your RLC circuit, what happened, the inductive and capacitive part will get cancelled with each other. Okay, get cancelled each other. So the total circuit will behave like a resistive circuit. So in that case you will get the resonance condition. So at the resonance condition, these two parameters, the graph of this capacitive reactance and the inductive reactance will cut each other. So overall the circuit will behave as a resistive circuit. So we are getting the resonance at somewhat between somewhere between 60 and 70 Hz. Okay, so I think this is understood by everyone. Okay, thank you. So today we are closing this. We will discuss on more topics on MATLAB, and how this can more other topics can be implemented in the MATLAB. We'll bring some other topics also. Okay, this is my first video. Please like my video as many as you can. Okay, and support my channel in this way. So till then, good night to everyone.